Hello, everybody. Welcome to section 2.1. This section covers function basics. The first section in chapter 2, which is going to be covering functions in general. So today we're just going to go over kind of some like the preliminary ideas as to like what a function is and what its attributes are. So let's get started. So let's talk about what a function actually is. So function is a rule that takes a set of inputs and for each element, so for each thing in that set, it assigns exactly one element in another set. So this is a lot of words. What does it actually mean? Let's try looking at a picture. So the usual picture people draw is we start with some blob over here, some blob over here, and let's call this one blob A and this one blob B. And I've got some points in A. Maybe they're numbers, maybe there's something else. Usually we'll be doing numbers though. I've got some other things in B, so probably also think of them as numbers. And so what F does is it takes everything in A and it assigns to it something in B. Exactly one thing in B, in fact. So my F could be something like, I could take this point and send it to that one. I could do this point and I could send it to that one. I could take this one and send it over here. And I could even assign the same point to two of them. So that's okay. I could do that. Good. So this is kind of a picture of a function. And you have to be careful because of this exactly one statement right here. What that means is that we can't pick one thing from A and give it two arrows. So I can't do something like this maybe, right? This, not allowed. We can't give two arrows to the same thing from our starting point. And so A and B actually have a name in function terminology. So terminology. So the first word is domain. The domain is the set that we start in. It's the set of all things the function is defined for. In our example, this is A, e.g. A. The other word that you're going to want to know is range. So this is all the values the function hits. Oops. There we go. So in our picture up here, the range would not be all of B because we missed this point right here. In fact, I think it would be these 4 points. Or sorry, not that last one. That arrow is not valid. It would be those 3 points. That's the range of F in this picture. So E, oops. E, G, the yellow. All right, cool. So there's a couple skills that we're going to want to develop when we're thinking about functions. And the first one is we're going to want to be able to evaluate. Wow, can't spell today. Evaluate function at like a point or several points. So this actually is fairly straightforward. So for example, we want to evaluate f of x, let's do equals square root of x plus 2 at the point 2. So to do that, we're going to take f of x, and everywhere we're seeing x, we're going to replace it with 2. So here in the function, all our x's, there's just one of them. It's right here. So we're going to take that x and we'll replace it with 2. So we get 2 plus 2, and that's just square root of 4, which is 2. So this is our answer. Let's look at another example. Let's evaluate f of x at x equals 1 for, and I'm about to write down like a really funky looking function. I'm going to do f of x equals, and I'm going to split it up into cases. I want to say f of x is x squared plus 1 if our input, if our x is bigger than or equal to 2, and I want to say it's 2x if our input is smaller than 2. So this is what's called a piecewise function. And they're actually fairly common. So learning to deal with them is actually a very good skill. But so how do we evaluate at x equals 1 with something that looks like this? Well, x equals 1, that's less than or equal to 2, right? 1 is smaller than 2. So we're going to do the first case. So f of 1 is going to be, we're going to use this case right here. So then we get 1 squared plus 1. Oh my goodness, sorry. That is not the case at all. Some of you are probably yelling at me right now because I'm doing this entirely wrong. It is less than 2, but that's not this top case. It's actually the bottom one, right? My apologies. We're dealing with this one because we are in this case right here. Yes, so 1 is less than 2, so we are going to use the second case, and if we plug in 1, we get 2 times that x right there. We need to replace with a 1, so we get 2 times 1, that's equal to 2. There we go. Good. All right, so evaluating function, even though I just totally dropped the ball, is usually pretty straightforward. So the next skill that we're going to want to develop is finding the domain of a function. And so we're finding a domain. There's a couple like basic functions we're just going to want to like know what the domain of them is. So the first one that you're going to want to know about is 1 over, actually let's not use x, let's use 1 over a, right? So a can be a polynomial, it can be another function, it can be just x. This is not defined for a equal to 0, right? Because then we would be dividing by 0, and that's very bad. The other one that you're going to want to know is the square root of a. Again, a can be whatever. This is not defined for a less than 0. So since we are only considering real valued functions, we are not going to do anything with negatives under the square root when we're looking at domains, at least in this section. So the square root is only defined for 0 and positive values. So everything else, though, the domain is usually basically everywhere. So for example, if we have f of x equal to like x squared minus 1, the domain is going to be everywhere because for any polynomial, is defined on all real numbers. So if you see a polynomial, you should think, ah, perfect, defined everywhere. Domain is negative infinity to infinity. Let's maybe look at something maybe a little more complicated with maybe some holes. So what if we looked at f of x equals 1 over, let's say, the square root of x minus 1. You know, this looks kind of weird and nasty, but we know two things. We know that the bottom part of a fraction like this, we know that this bottom part cannot be 0. And we also know that the square root is only going to work for positive things. So we want the thing under the square root, which in this case is x minus 1. We want that to be greater than or equal to 0. Or sorry, yes, that is correct. All right, so let's split this up. Let's look at the first one. So if it were the case, so if we did have this bad one where that was equal to 0, then that would mean we would have to have, if we square both sides, x minus 1 equals 0 squared is 0, which means if we add 1 to both sides, x equals 1. So we know that if we don't want this to happen, x can't be 1. Cool. For the other one, if this thing right here were negative, so if x minus 1 was less than 0, then if we add 1 to both sides of this, we see that x would be less than 1. So by the same kind of idea, since we don't want this to happen, x can't be less than 1. So we know that x can't be less than 1, and also x can't be 1. So our domain is going to be everything else. So everything strictly greater than 1. All right, cool. What about finding the domain of a piecewise function, right? So for example, what if we had f of x equals, let's write this piecewise function as maybe 1 over x minus 2 if x is greater than or equal to 0. And let's do x squared if x is less than 0. So the rule for piecewise function is the domain is going to be whatever the domain of the first case is unioned with the domain of the second case. So what we're going to do is we're just going to look at them case by case. So the first case is what was it? Oh yes, 1 over, so f of x equals 1 over x minus 2. And this is for every x greater than or equal to 0. So since it's already, we know that it's only defined here for this case, right? So we know from like our previous work that x minus 1 can't be 0. So x, so if we were to write this out as 0, that would mean that x would be 2. So that means x can't be 2. And since this was defined for everything greater than 0, including 0, but we know that the domain of like this, oops, my bad. The domain of this piece right here is everything except 2. It's going to be, the domain will be what we started with originally. So 0, infinity, take away 2, because then we'd be divided by 0. So we don't want 2 in there. So we get 0, 2, union 2 to infinity. There's actually another way you could write this. So, or we could write 0 to infinity, and then backslash the point 2. This backslash just means take away. So you're welcome to use this kind of notation right here in your homework if you wish. Okay, that was the first case. Let's look at the second case now. So for the second case, x squared, f of x equals x squared, that's a polynomial, right? And so this was defined on x less than 0, but x squared, okay, everywhere, because it's a polynomial. So the domain of this second case is just going to stay this. So it'll be negative infinity to 0, like that. So then if we look at the domain for the whole piecewise function, that's going to be, so our first domain was 0 to 2 and then 2 to infinity. So we have 0 to 2, union 2 to infinity. And then we're going to union that with the second case, which is infinity 0. And this is a complete answer. Cool. Now, the third and final skill in this section that you're going to want to develop is finding the range. And finding the range is a little bit different from finding the domain. So in order to find the range, we're first going to look at the ranges of some common functions. So common ranges. And we'll use these as kind of like a jumping off point. So if we have mx plus b, so if we have a line, that range is all, it's everything. So if we're going to write that in set notation, negative infinity to infinity. Yeah, because the line, it goes off to infinity, goes off to negative infinity. There's no problems with it. There's no hole. There's no wiggles. It's all good. Cool. If we look at a polynomial, let's look at it in just like the leading term. So if we have something to the nth power, there's two cases. So this will always be greater than 0. So 0 to infinity if n is even. So if it were 2 or 4 or 6, it's going to be greater than 0, greater than or equal to 0. If it's odd, though, it's everything. Cool. Let's look at something else. Let's do, if we have 1 over a, so if we have some sort of like rational function, we know this, you actually can't achieve 0 with this kind of rational function. So the range for this will be infinity to 0, union 0 to infinity. Or if you so wish, this take away 0. Cool. Square root of something, the square root is actually also going to be always greater than or equal to 0. So, oops, that domain is 0 to infinity. And last but not least, the absolute value of a. Absolute value makes everything positive, so you're going to expect it to do something very similar. So that range is also going to be 0 to infinity. These are kind of worth just knowing and memorizing because most ranges that you calculate can be found by kind of looking at these and kind of building off these cases. So let's look at some examples. So example, range of, oh, let's do something simple for first time. Let's do 3x plus 1. Or yeah, that'll be good. This is a line. And if we look back up at our little table up here, lines are, their range is everywhere. They cover the whole real line. So this range is going to be negative infinity to infinity. All right, no extra work needed to do there. Good. Let's look at something maybe a little more intense. Let's look at the range of, and then let's do f of x equals, and let's do x squared plus 2. So we know that x squared is going to be greater than or equal to 0 for any x we plug in. And that's since 2 is even, right? 2 is an even number. And by our rule up here, that means it has to be greater than or equal to 0. And so then if we add 2 to both sides of this inequality, we get x squared plus 2 is greater than 2. X squared plus 2 is our function. So we know that, oops, that's not what I meant to do. We know that f of x is always going to be greater than or equal to 2. So the range is going to be 2 to infinity. Cool. All right. Let's do another example. Let's do the range of f of x, and let's do something rational maybe. Let's do 1 over 2 minus 2. So we know from our little table up there that we can't have something rational equal to 0. So in this case, our a is going to be 2x minus 2. So 1 over 2x minus 2 can't be equal to 0. And that's our function. So we have f of x can't be equal to 0. So this is going to be negative infinity, 0 union 0, infinity, or positive infinity, or if you so wish, infinity infinity take away 0. All right. But again, you might be wondering, well, how do we look at the range of piecewise functions? Actually, the rule is the same. So if we were to look at, actually, no, I'll just write down the rule because it's the same as looking for the domain. So note, range of piecewise functions is constructed the same way as their domain. That is, so if we're looking at the range of piecewise function, that would be like range of first case unioned with range of second case. All right, I'm going to do one last example as like a cautionary warning, especially about piecewise functions, because they're usually only defined on like a subset of the real numbers for each case. So if, for example, we had f of x equals 3x minus 2, so like a simple line, but we are only defining it on, say, -5 to 2, right? We want to know, oh, what the heck's the range of this? Well, what we're going to do is we're going to start with this. So we're going to start with -5 less than or equal to x less than or equal to 2. And then what I'm going to do is I'm going to multiply everything by 3. So I get -15 less than or equal to 3x less than or equal to 6. And then I'm going to subtract 2 from everything. So I get -17 less than or equal to 3x minus 2 less than or equal to 4. But that's our function. So we have 17, or -17 less than or equal to our function less than or equal to 4. So our range is going to be 17, or -17 to 4 inclusive. So that's how you find the range of something where you have a restricted domain like this. Okay, cool. This was a lot of information to process. Functions aren't easy, especially the first time you have a go at them. So be gentle with yourselves, keep working on the homework, and if you have any questions, of course, I hope to see you in office hours.